Okay, here we have a problem. A truck is moving at a rate of 35 miles per hour. The diameter of its wheel is 20 inches. We want to find the rotational speed in revolutions per minute, and we want to round to the nearest thousandth. So we're given a rate. So we're given this rate of 35 miles per hour. And we're asked to change this rate to another rate, which is rotational speed. So if this blue highlight is rotational speed, what is the orange highlight? The orange highlight is linear speed. So linear speed compares let's say distance in units per unit of time. Distance in some time of unit per unit of time. I don't think I wanted to say distance per unit. I want to say unit of distance. No, is that what I want to say? Yeah, I guess distance per unit of time. How about that? Distance, linear distance per unit of time. Distance per unit of time. How about if I do this? Miles per hour. That would be a distance per unit of time. Or another example might be feet per second. Or another one might be kilometers per minute. So lots of different ways to show your linear speed depending on the unit of measure that we're talking about. So that's our linear speed. And we're all familiar with that. It's the speed limit, right? 40 miles per hour. How far did you walk? I walked a mile in 18 minutes and 20 seconds. Okay, then we have our rotational speed. And there's two different types of speed that we can talk about here. Rotational speed is one of them. Rotational speed, and I mean, there's two different types that we can talk to about going from linear speed to something else. Many times we talk about rotational speed, and that's revs per minute, revolutions per minute, revolutions per unit of time, usually per minute, but it could be revolutions per second. It depends on what is, what's rotating. And then you've got angular speed. And angular speed is probably the new one, the one that you've never heard of before. Revolutions per minute, revs per minute, RPMs. You've heard that before, maybe in a movie or somewhere. But angular speed, I doubt very seriously that they're talking about radians per unit of time. That's your angular speed. Okay? So we've got three different types of speed. And what's interesting here is that we've got, linear speed. I'm going to kind of highlight that in orange. When you're going from linear speed to either one, the rotational speed or the angular speed, the only way to get from one to the other, is through the circumference. Okay, so keep this in mind. You got to get there through the circumference, which is either 2 pi r or pi d. Okay. Now, if I'm going from rotational speed to angular speed, I don't have to go through circumference. Angular speed to rotational, rotational to angular, don't have to worry about the circumference. But as soon as I put that linear speed in the mix, if I'm going from linear speed to either one, rotational or angular, I have to go through the circumference. If I'm going from either one of these back to linear speed, I have to go through the circumference. So now that you understand, hopefully, why we're using circumference or when we use circumference, now you'll see, I'm going from linear speed to rotational speed. I need the circumference, and it's the circumference of the wheel that I'm going to need, because it's really the wheel that's going to determine our distance. So if I take a wheel, I don't even know how I can draw this. I'm going to try. So I've got a wheel. If I open up that wheel, right, here's my wheel with a radius and now a diameter, right? If I open up that wheel, let's take that away. I take that, let's just say I cut it open. So this is the bottom, right? So I'm going to open up this flap. When I open up that flap and I lay it flat, it's like that. Okay, that's a radius, right? And if I open up this, let's just say I cut this wheel and I open up this part and I lay it flat, it's going to lay flat like that. And that's another radius. So my distance all the way around the circle is 2 pi times the radius. Right? We know that. That's your circumference around. So this is going to be 2 pi times the radius. And sometimes we're given 2 radiuses is the diameter. And then if we say, okay, well, it does 1 revolution, then it's going to go this distance per that unit of time. And then if it does 2 revolutions, look at that, then I'm going to have 2 of those per unit of time. And that's what we want to do, is we want to take these revolutions, we want to figure out how many of these wheels are cut open and laid flat. So if I am rotating 5 revolutions, I would have 5 wheels that were cut open, right, and laid flat. So we don't have to worry about doing that. We can just do it mathematically, right? We're not going to cut open these wheels. So we're going to start with the given ratio. So the given ratio is 35, I believe, miles per hour. I'm going to check it because it's not on my screen anymore. 35 miles per hour, yes. And then I'm going to end, we're going to do Phoenix Suns colors right here. We're going to end with the ratio we want. So that's what this is going to equal, the ratio that we want. And the ratio that we want is revolutions per minute. So how do I get from hours to minutes? Well, we're going to multiply by unit conversion. 1 hour is the same thing as 60 minutes. So this right here is a value of 1. Anything over itself is 1, and 1 hour is the same thing as 60 minutes. So we're going to not change the value. We're going to just change what it looks like. So now my hours go away, and I've got minutes in the denominator, which is what I want, right? Minutes in the denominator. So we're done with converting the time. Now we need to convert miles to revolutions. So remember, every revolution is going to be 1 circumference. So 1 revolution is going to be 1 circumference, and 1 circumference is 2 pi r or pi d. And since they gave me the diameter is 20 inches, I'm going to use pi d. So pi times 20 inches. And don't forget your label of inches. Nothing's canceling out, right? So I've got my revolutions in the numerator, but now I've got miles and revolutions and inches. So I need to get rid of this, and this right here is a value of 1. Now I need to get rid of the inches. So I can either say 12 inches in 1 foot and then 5,280 feet or in a mile, get rid of it that way. Or I can say, since I ran out of room, 63,360 inches are in 1 mile. So the inches cancel out, and now the miles cancel out as well. And in the numerator, all we have is revolutions, which is what we want. And in the denominator, all we have is minutes, which is what we want. So now all we have to do is 35 over 1 times 1 over 60 times 1 over 20 pi times 63,360 over 1. If you're doing this in your calculator, please just make sure that you're using parentheses so that it groups all of the numerator multiplied together and it groups all of the denominator multiplied together. And then I don't think I have this on my calculator any longer. I might still have the answer. No, I don't. So I'm going to have to put this back in. Otherwise, I have to change to another page. 35 times 63,360. And I'm going to divide that by all of, so I'm using parentheses, 60 times 20 times pi. And I got 588.237 revolutions per minute. So hopefully that helped you. Hopefully explained when you use circumference, which in most cases we're going to be using the circumference because we're almost always going to go from linear speed to one of these two or vice versa.